All right, so I want to go through this chapter 1, 2, 3 study guide. First problem here, it says there's 90 children let loose in a toy store, and the amount of spent per child is summarized in the table below. All right, so this is a frequency table, but the data has been grouped, and so they want us to estimate the mean. In order to do that, what's going to happen is that we are going to need one value to represent each one of these classes, and we're going to pick the mid class value. So in this case, it's going to be a 15, and then between here and here, it's going to be 40. And between here and here is going to be 60. And between here and here is going to be 80. All we've got to do is add the two ends together and divide by 2. So now to estimate the mean, what's going to happen is I'm going to demonstrate I know how to do it by hand. I'm going to do 15 times 6 plus 40 times 35 plus 60 times 33 plus 80 times 16, and that is all going to be divided by the sum of the frequencies, which is going to be 90. And now, after I've written this, I'm going to go to my calculator. I'm going to do menu 6, and I'm going to plug in the one variable statistics. I'm going to plug in each one of these values and then the frequencies. And then what I'm going to do is I'm going to push option, and it's going to do the one variable calculations. And I'm going to find that the mean for this is 52.77. All right, so this written right here is the method, and that's all you've got to show you know how to do it by hand. And then after that, all you've got to do is put it in there. Keep in mind the formula for this is basically the sum of the x's times the frequencies, all divided by the sum of the frequencies. And this is a formula that will be on your test. They'll give it to you, so don't worry about that. All right, now we're going to estimate the standard deviation, and basically it's the same kind of thing. I mean, that formula is, and what I'm going to do is I'm going to do variance. Keep in mind that standard deviation is just the variance, the square root variance. So if I'm going to find the variance, that's basically going to be the sum of the x's squared times the frequency, all divided by the sum of the frequency minus the mean squared. Okay, and again, this is going to be on your formula sheet. Actually, it'll be a standard deviation, so they'll have the square root sign around it. But this is all I need to know. So what I'm going to do is basically the same thing. But I need to show that I know what I'm doing. And so if you want to, you can just go like this. Standard deviation is equal to, put a nice big square root sign, and then it's going to be 15 squared times 6 plus 40 squared times 35 plus 60 squared times 33 plus 80 squared times 16. And see, the nice thing about this is it looks almost exactly like what you've written over here, except for the data values have been squared. And so now what's going to happen is that I'm going to still divide that by the sum of the frequencies, which is 90, And then what I'm going to do is I'm going to subtract the mean squared, which I've already figured out the mean. That's going to be, and again, you notice how this got 7, 7. It really was 7, 7. I am going to make sure when I put this on here, 52.77, and then it's supposed to be squared, okay? And see now, all I got to do is look at my calculator, and the value is already in there, and it's going to look like this, and it's going to show you that the standard deviation was 17.6. It was actually 17.5927, but then we'll round three single figures and get 17.6. Okay, so that's what I got for that one. And then we're going to estimate the median. So keep in mind, basically when you're doing this, we're thinking about a proportion. We need to figure out roughly where our median is. And since we're estimating, we know we've got 90 pieces of data, and we're going to multiply it by 0.5. And we know that it's going to be the 45th piece of data. So if I go along here and kind of count, so here I've got 6, and then here I've got 41 altogether. This is the cumulative frequency. And then here I've got 74, and then here I've got 90. All right, so I haven't got to the 45th piece of data here, so it must be in this class right here. It's got to be in the 50 to 70 class. All right, now the question is it where, or what, approximately where? Well, what we're going to do is we're going to figure out roughly how far we're going to go into this number, and then we're going to apply that value to the class proportionally. So basically, if we've got 41 used up, I've got to go 4 more into 33. So that looks like this, 4 into 33. All right, now I'm going to compare that to how far I have to go into the class. And I don't know how far I have to go into the class. That's what I'm trying to figure out. But I can tell you the class width, it is 20 wide. And see now, like any proportion, if you've got two fractions equal to each other, all you've got to do is cross multiply. So this is going to be 80 is equal to 33x, and x is going to equal 2.4242. Now keep in mind, x is not our median. X is how far we have to go into the class. So the next thing is we have to figure out where the class starts. In this case, you can see that there's no gaps, so the class starts at 50. And so what's going to happen is that we're going to add 50 to this, and we're going to get 52.4242. Okay, now, if you think about it, it kind of makes sense. All right, this class has got 33 pieces of data in it, but we're only going 4 into it. We're not going very far. This class has got 20 pieces of data in it, and we're not going to go very far. Proportionally, we're going to end up around 52. So that's how I figured out that, and that's our approximation of the median. Now, the largest possible interquartile range. So we've got to figure out roughly what classes the Q1 and Q3 are going to be. And so to figure out Q1, I'm going to again take the total 90 and multiply it by 0.25, and I'm going to get 22.5. And then I'm going to do Q3, and again it's going to be 90 but times 0.75, about 3/4 of the way, and that's going to get me about 67.5. All right, now the 22nd.5th piece of data is definitely going to be in this class right here. Let me use a different color. This is where it's definitely going to be. All right, because we've only used up 6, So the 25th is definitely going to be in here. And the 67th, well, we've used up 41, and then we go another 33. The 67th piece of data is definitely going to be in here. All right, so our Q1 is in here, and our Q3 is in here. Now, if they were to ask us to estimate it, then what we would do is kind of the same procedure what we did with the median. But they didn't ask us to estimate it. What they asked us was the largest possible interquartile range. So the largest possible one is if I pick the biggest possible Q3, which is 70, and then subtract the smallest possible Q1, which is 30, and we'll find out that the biggest possible IQR is going to be 40. All right, hope that makes sense. Now let's take a look down here. Okay, when we're doing a histogram, make sure that we are going to label it, because that's an easy point. And when you're doing a histogram, the easiest thing to do to start off with is go ahead and just label it. And so I'm telling you right now, this is always going to be frequency density. All right. Now, if you go up to the table, this is the x-axis and this is the y-axis. So the y-axis is going to be the frequency density, because we're going to figure out. So actually, I'm going to put that somewhere else. But the x-axis is the amount of money spent. So let's put that here. Amount of money spent. And then I need units. And in this case, if I just use a dollar sign, then I'm telling people that I'm using dollars. All right, so now I need to know frequency densities. And the way I figure out the frequency density is I'm going to take each frequency and divide by the class width. All right, so let's see. Let's go and put this, I'm going to put it down here. Okay, so frequency density, 6 divided by 30. So let's go. Okay, so 6 divided by 30 is 0.2. And then we're going to do 35 divided by 20. And that's going to be 1.75. And then we're going to do 33 divided by 20. And that's going to be 1.65. And here I'm going to do 16 divided by 20. And that's going to be 0.8. All right, so and next to my problem, I've written how I've figured out the frequency densities, and I've labeled the frequency densities. All right, it's going to make it a little bit easier for the person to grade it to see. All right, so now what's going to happen is that I am going to go up here and look at my classes. My classes go from 0 to 30. Well, actually, let's look and see. Look at, you notice how my x-axis is going to go from 0 to 90. All right, so if I look at this, it kind of makes sense if I go by tens. And you don't have to label every single one. So like, for example, if you went like this, everyone's going to know that these middle numbers are 10 and 30 and 50, and you certainly can figure that out. So you can save a little bit of writing. And then we look at our y-axis, and we go from 0.2 to 1.75. And so we take a look at this, and if I go 0.2, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, and 1.8. And what's happened is I've used up almost the entire axis, and I've spread this out as far as I possibly can. It doesn't make a difference which units you use. If you didn't use the same thing that I did, it's not necessarily wrong, as long as your scale is consistent and that you use a decent portion of the graph and not just make it super, super small. So anyway, when I look at my classes now, the first class goes from 0 to 30. So that's going to go from here to here. So I'm just going to put a little mark. From 0 to 30. And then my next class is going to go from 30 to 50. So to 50. And then I'm going to go 50 to 70. And then 70 to 90. Part of the problem is I can't see the whole paper at one time. And I'm going to use this drawing thing here to try to help me out. All right, so if I go, and my first one is from 0 here, and it's a 0.2. So I go up, and I go across. I go down, and then my next one is going to be 1.75. So I take a look at this, and you see that it goes from 0.8 to 0.6. So that's 0.2, and you'll notice that it goes, there's 1, 2, 3, 4, 5. So if I take 0.2 and divide it by 5, I'm going to find out that each one of those is a 0.04. So this is 1.64 right here, and this is 1.68, and this is 1.72, and this is 1.76. So what happens is it's probably going to go like right here in the middle, and I'm going to put a line that goes across here. And it goes, and I'm trying to watch. And then I'm going to go down. And you need to make this neat and relatively accurate, but you also don't want to spend all day doing it. All right, so the next one is 1.65, and again, I said this was 1.64, so this is going to be a little bit taller than that. And it's going to go to here. And then my last one's going to go to 0.8. And that looks nice. And I'm in good shape. You're generally not going to color it in. You want people to see the squares. You don't want to spend an extra time on this than you have to. You make sure it's labeled, and then you move on. All right, so now this next part says that we want to do the cumulative frequency graph. Now, for a cumulative frequency graph, we need points. And what's going to happen is it's going to be this lower value and then 0. So I'm going to write the points now. My first is going to be this lower value and 0. It's always going to be whatever this lower value is and 0. So let's go here, and let's say my points are going to be 0, 0. And then I'm going to pick the end of each class. So this is going to be 36, because I'm doing the cumulative frequency. 30 and 6. And then my next one's going to be 50 and then 41. And then I'm going to do 70 and 74. And then my last class is 90 and 90. All right, so now I'm showing people what my points are, and now I've got them right here, and I need to draw my scales. And you know that both scales, or in this case, both go to 90. So I'm going to use, let's see, it looks like tens. So this would be 20, 40, 60, and 80. And this would be 20, 40, 60, 80. And we have to label them. This is always going to be cumulative frequency. And this is going to be, again, whatever is on the x-axis, which again is the same as the histogram. It's the amount of spent in dollars. All right, so now all I got to do is plot my points and connect them with a straight line. So I got 0, 0, and my next point is 30, and then 6. So if you take a look, if this is 10, these must be going by 2s. So that means I'm going to go 30 and then up 1, 2, 3. Put a point there. And that gives me my 36. And then 50, 41, 50. And then 41. Now again, they're going by 2s. So it's just going to be like right here in the middle. And then 70 and 74. So I've got 70. And this is 70, and again, they're going by 2s, so I'm going to put a dot right there. And the last one is going to be 90, 90, and so that puts it right here. And see, now keep in mind what I'm going to do is I'm going to connect these with a straight line. There are two different versions of this. It's possible you're given one where it's a curved line, but you're going to always make it a straight line. And when you're taking your actual exam in the spring, the book that has all the formulas in it will be a great tool to use for straight lines. And it doesn't have to be perfect, but you do need to be a little bit careful, okay? Because what's going to happen is it's possible they're going to ask you to figure stuff out. And if you have been sloppy about creating it, well, it's not going to work out very well. So now they want it the IQR, and again, there's no way for us to see the actual data, so we're going to find the quartiles by multiplying, and we're not going to add 1 to it. So the total pieces of data is 90, so Q1 is going to be 90 times 0.25, that's the first quartile. And that's going to give me 22.5. And then Q3, that's going to be 90 times 0.75. And that's going to give me 67.5. And mind you, if they had asked for the median, I would just do 90 times 0.5. Now keep in mind, this is roughly the place of the data. And the numbers along the y-axis are the numbers of data. They're the frequency, how often they happened. So I'm going to go to 22.5. So here is 22, and this is 0.5. And so now 22 and then 0.5. And so then I'm going to go across and down. And that looks like that's going to be either 40 or 41, depending on how you did it. So we're going to say Q1. Okay, it's going to be pretty close to 40. All right, don't be afraid. Don't just automatically round to the one below. or the closest to it, you know, try to make it as exact as you can. And so then 67.5, 67, 2, 4, 6. So 7 is right here. And again, that looks like that lines up pretty close, but a little bit before, possibly. Let me use my straight line thing. Maybe a little bit on this side. And so again, if it's going by twos, 62, 64, we're going to say 65 or 66. So what should happen is that you should get an IQR of somewhere between, if I did 66 minus 40, that would be the biggest one. So that would be 26. Or maybe 65 to 41, which would be 24. If your IQR is somewhere around 24, 25, or 26, then my expectation is you probably get credit for this. All right, so keep in mind, there's going to be a range, and you know, I'm not sure if you're drawing it, the range will be a little bit more generous. If they've drawn it, then they'll be a little bit less generous. But that's how this is working. Now, the other possibility is that they don't give you a value on the y-axis, they give you a value on the x-axis. So they say we want to find the number of the shoppers that spent more than 60. All right, so the people that spent more than 60 are these people. Here's 60 right here. And all of these people spent more than 60. So what I want to do is find out where that line breaks. And if I take 60 and go up, it puts me right here, which looks like it's a little bit below. And we're going to say, whoops, well, I kind of moved it. I'm going to say that it's going to be 60 or 59 based on what I've drawn here, but it's going to be something close to that. 59, maybe 58, depending on how yours is drawn. 59, 58. Okay? Now, what's going to happen now is that you've got to tell which ones are more than that. Okay? Now, I can tell you that 59 or 58 people spend less than that. The people that spent more than that are up here. So what I've got to do is I've got to do 90 minus 59 or 58, and I'm going to get about 31 or 32. Okay? Hopefully that makes sense. Let's take a look at the next part. So in this problem, it says that we've got Jillian Michaels teaching a yoga class, and there are 12 class members. And so what I'm going to do is start pulling this data down out of the paragraph so I can access it very easily. All right, so that means there's 12 pieces of data, and they're telling me right up front that the mean is equal to 48.7, and they're also telling me it's standard deviation. Standard deviation is equal to 7.65. Now there's another class, and it's got 7 people in it. So let's say n is equal to 7, and then the mean is equal to 38.1, and the standard deviation is equal to 4.2. All right, So now what I've got to do is figure out the mean of both classes together. And because we know the both classes, so this really should say together. All right, so in order to do that, basically the formula is I'm going to use the sum of the x's plus the sum of the other x's divided by each n, added together, and that's all I need to do this. So the problem is I don't have that information, but I can figure it out. And the first thing I'm going to do is go here, and I'm going to do the mean, which is 48.7 is equal to the sum of the x's, whoops, that was terrible, divided by 12. And so that means that the sum of the x's is going to equal 584.4. Because all I'm going to do is multiply both sides by 12. And then when I come down here, I'm going to do the same kind of thing. 38.1 is equal to the sum of the x's, but this time it's divided by 7. And so the sum of these x's is going to equal 7 times 38.1, or 266.7. And see, now all I've got to do is take these two pieces of information, 584.4 plus 266.7 divided by 19, and that's going to give me the mean of both of them, which is 44.79, and the units are years, so it's still going to be years. All right, so that's how you find them both. You need the sum of both of the x's, and either they're going to give it to you or they're going to give you some way to figure it out. Now, in part B, they want to find the standard deviation of both classes, and again, together. Now, the formula for that is going to be the sum of the x squares plus the sum of the x squares divided by n plus n, and then minus the mean of both, and see, in this case, we're going to have the mean of both because we've just figured that out. So I'm just going to write the mean of both. If I didn't have that, then I would need the sum of both x's, and, well, kind of like what I did over here. All right, now keep in mind the standard deviation, that's going to be the variance. So if I want to actually find the standard deviation, I'm going to take the square root of all that. So when I'm going to do this now, this formula I've written up here is for standard deviation, and if I made it variance, well then all the variance is the standard deviation squared. So what I'm going to do is I'm going to take the standard deviation, 7.65, but then I'm going to square it. See, now it's the variance. And so when I do the formula, I don't have to worry about the square root sign. If I put the square root sign, all that would happen is that my first step would be to square both sides. So I'm just kind of skipping that by squaring this standard deviation and changing it into the variance. So now what I'm going to do is I'm going to have the sum of the x squares over 12 minus the mean 48.7, and that's going to be squared. And see, all I'm going to do now is take 7.65 squared, I'm going to add 48.7 squared to that, and then I'm going to multiply it by 12, and that's going to give me the sum of my x squares is equal to this number right here. 29168.0688. And then I'm going to do the same kind of thing with the other one. I have the standard deviation is 4.2. I'm going to change it to the variance by squaring it. And so now I'm going to have the sum of those x squares, but this n is 7, and then minus that mean, which is 38.1. and then divide that, or square that, and see, same kind of thing. I'm going to do 4.2 squared, I'm going to square it, or 4.2, I'm going to square it, I'm going to add 38.1 squared to both sides, and then I'm going to multiply that by 7, and that's going to give me a sum of x squares is equal to 10284.75. And see, now all I got to do, I've got my x squares. I'm going to take this and put it in the regular formula. It's going to be, the standard deviation is what they asked for. So I am going to square root, and I'm going to do 29168.07 plus 10284.75 and divide that by 19, and then I'm going to subtract the mean of both, which I already figured out is going to be 4.79 squared. And I have to be careful because I probably should put some digits on this. The actual answer for this other one over here was 44.7947. And I'm probably going to put them in here. All right, because it's in the middle of the problem and I want to round as little as possible. But anyway, once I do that, I'm going to get a value 8.3857. And if I round to 3 significant figures, 8.39. And that's what I get for that. All right, so let's take a look at the next one. Again, this is one where I screwed up. There's a typo on your paper. It's going to say 207. It should just say minus 20. Apologize for that. So keep in mind, when I'm finding the mean, if I want the mean, well, I've got to change it because the coded data is not going to give me the actual mean. But if I take the negative 20, which is the sum of the x's, and each one's been subtracted 82, but if I do the sum of the x's minus 82, and divide by the number of things, which in this case is 30, all right, that's going to give me the coded mean. They want the actual mean. So what I'm going to do now is add 82, and the actual mean is going to be 81.333. All right? Now, when I'm figuring out the standard deviation, or the variance, then what I've got to do is I've got to make sure that I'm always using coded data. All right? So even though I've found the mean, it's the actual mean. But the problem is that I only have coded x squares. And so if I go to do this by using the formula, well, I'm going to do the squares. And so what I'm going to do is I'm going to do the variance first. So what that's going to be is 952 divided by 30. That's a sum of the x squares divided by 30. And then I'm going to subtract, and now I'm going to do just negative 20 over 30 squared. Okay? Now, when I do that, I get a variance of 31.2888. And see, keep in mind, when I'm finding standard deviation or variance, if some of the data is coded, then all of the data has to be coded. So that gives me that. Now, what they actually asked for was the standard deviation, so that's going to be the square root of 31.288. And while it's still in your calculator, all you got to do is square root it or raise it to the 1/2 power. That's going to equal 5.5936. Okay, so then the next thing we've got is this stem and leaf diagram. If I've got a setup like this, well, they want me to find the median and the IQR for each side. Again, I didn't give you tons of room. So here, what we're going to do is I'm going to go like this. Let's see. Let's do the A side over here. All right, so now if I'm going to do the median and I've got actual data, which I can translate this into actual data and note the key, all right? So for example, this number right here is not 151, it's 0.151. And this is not 161, it's 0.161. So what I'm going to do is that I'm going to add all this up. And when I do, I find out that there are 33 pieces of data on the A side, and there are 31 pieces of data on the B side. I'm going to do each side one at a time. So first I'm going to find the median, and if I got actual data, what I'm going to do is I'm going to add 1 to it. It's the number of pieces. So for the median, I'm going to take 33 plus 1 and then divide by 2. So that's 34 divided by 2. That's going to tell me the 17th piece of data is going to be my median. And see, what you got to do is kind of make sure. Now notice how these are going from smallest to biggest. So that means this is going to be the first, the second, the third, fourth, fifth. And see, if you want, you can even just look at these numbers. Here I've used up 5 pieces of data. I need to go to the 7th. Now I've used 8 pieces of data. So now I know it has to be somewhere in here. So by just looking at these numbers, you can save yourself a little bit of time. These all are 8. So this is 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Oops, sorry, I want 17. So that means this one right here is the 17th piece of data, and that number is going to be 0.186. All right, now to find the IQR, I need Q1 and Q3. And again, because I'm looking at actual data, I'm going to add 1, but keep in mind the Q1 is the median of the lower half. In this case, there were 33 pieces. My median is here, so that means that there are 16 below and there are 16 above. So that means there's 16 pieces in this, and so to find my Q1, what I'm going to do is I'm going to take 16 plus 1 and divide that by 2, and I'm going to get 17 divided by 2, which tells me it's the 8.5th piece of data. So that means it's between the 8th and the 9th piece of data. So again, take a look at these numbers. There's 3, there's 2, that's 5, and there's 8. This is the 8th piece of data right here. So that means that my median is between this one right here and this one right here. And so if you want, you can write them down. My median is going to be between 0.180 and between 0.178. It's going to be exactly in the middle. Now, if you add those two and divide them by 2, you'll find out that the Q1 is going to be 0.179. But you can kind of see that, right? Okay, so that's Q1. And now Q3. Q3 is also going to be the 8.5th piece of data. Now, I can start after the median. I can go 1, 2, 3, 4, 5, 6, 7, 8, and then see that it's going to be here. Or I could go backwards. 1, 2, 3, 4, 5, 6, 7, 8 and a half. It doesn't really change it. It's going to be between those 2 digits. And the thing is, that means it's between 0.198 and 0.198. Well, the average of those two is going to be 0.198. So that gives me a Q3 of 0.198. And so if I want to find my if I want to find my IQR, it's going to be 0.198 minus 0.179. Oops, I'm screwing up here. 0.198 minus 0.179. And that's going to give me 0.019 IQR. And now what I'm going to do is I'm going to go over here and we're going to do part B, because again, I didn't quite give you enough room, I don't feel like, but it's going to be the same basic process. I'm going to find the median, and I know there's 31 pieces of data, so if I do 31 plus 1, that's going to be 32. 32 divided by 2, that tells me that it's going to be the 16th piece of data. And so again, if you take a look at these numbers, I know that these two rows represent 14 pieces of data. So then all I got to do is go 15 and 16, and that lets me know that this is going to be the median, which is going to be 0.171. All right, now again, if there was 31 pieces of data and the median is that number, that means there's 15 below and 15 above. Okay, so now what I'm going to do is I'm going to find the Q1. Q1 is going to be 15 plus 1 divided by 2. It's going to be the 8th piece of data. So here's 4. So 5, 6, 7, 8. That gives me 1.64. Or, yeah, 0.164. That's Q1. Q3 is also going to be the 8th piece of data, either after the median or from the end. It doesn't make a difference. So if I go here, 1, 2, 3, 4, 5, 6, 7, 8, that puts me right there. Or I could go backwards. 1, 2, 3, 4, 5, 6, 7, 8. You see I end up in the same number. But anyway, that's it. So it's going to be 0.179. And so to find the IQR, I take 0.179 and subtract 0.164, and I'm going to get 0.015 as my IQR. And the last part right here is ask what the advantage of a stem and leaf diagram over a box and whisker and a histogram. Well, there are a couple nice things about a stem and leaf diagram. One is that you can see the distribution. You can see where it's grouped together. But the thing is, box and whisker and the histogram both offer that. So that's not an advantage over the other two. The only real advantage over this is that for the stem and leaf diagram, you can see the real or the raw data. Okay? So for example, in this case, if I wanted to, well, number one, I'm not estimating the median, I'm found the actual median. If I was given a box and whisker plot, well, the median hopefully would be on there, but I mean, if it was a histogram, I would have to be estimating it. And if I wanted to, I could change all this to real data and I could find the actual mean, which again, I can't do with either of these other two. So the ability to see the raw data or convert it to raw data, that's the only big advantage. All right, so now keep in mind, in this table I gave you, the data has been grouped and there are no gaps. If there is a situation where it is going to be having gaps in it, then there are some things you've got to do a little differently. It's super important to make sure that you go back and look at the other papers from this unit, from chapters 2 and 1, where those worksheets I gave you, where we did this same kind of stuff, either find the mean or the median or the standard deviation with grouped data, but it had gaps in it because it changes things. Same thing with the cumulative frequency graph. Make sure you're looking over all those sheets that we've done. All right, that's all I got for you today. Thanks for watching.